Let's discuss about frequency distribution tables and graphs. This is a topic related to statistics. Now coming to this topic, initially statistics is very much related with data. So what is a data? The most important factor of the topic of statistics is data. Without data, you cannot estimate or you cannot get into the topic of statistics, and hence cannot get into the topic of frequency distribution tables and graphs. So what is a data? Data is collection of minimum information and then trying to draw conclusions out of it. Say for example, I have a car moving on the road. So I just calculate the time and the speed, which is nothing but data. I calculate that the first hour the car goes at 40 kilometers per second. Then I assume that, then I also calculate with the next time after 1 hour, I calculate the speed of the car, which might be around 60 kilometers per hour. So then I calculate again for the third hour, which again might be the speed with 80 kilometers per hour. So with this different calculations of the speed, I am nothing but collecting the data. So that data will help me in drawing conclusions in various ways. I just want to say, for example, I calculate the population of the country for 2013, 2014, 2012, 2011. Then I can make a conclusion on how much of the population is increasing every year. Then what precautionary measures I can take to control the population. So the data of the population which is collected every year helps me in estimating the population increase or rise in population and then controlling measures taken immediately as a cause. So that is where statistics comes into existence, with the minimum data information which we collect before we draw conclusions. So this is where we will see what exactly the data is. The minimum information, it can be either the verbal form or it can be the numerical form. It can be either the verbal form or even the numerical. It can be numerics, or it can also be in the form of graphical representation. So the data which you're going to collect can be in three different forms. One is the verbal form or the numerical form or the graphical form. So my definition says that the minimum information which I collect from different ways, either in the verbal form or the numerical form or the graphical form, which helps me in drawing conclusions, is called data. So this minimum information which I collect and then study or research or experiment on that given information is called data. So that is how the data helps me in statistics. And the drawing of conclusions can be in various ways. So let's take an example. For example, data of population of the country every 4 years. Now in this case of an example, let's see one of the example for how a data is collected and how we can draw the conclusions. In case of an example where I collect the data of population of the country every 4 years, the census, which happens in the governmental department every 4 years, there is a department which collects the population of the country, and that recorded data can be used as the best example for how a data collection is done and how the conclusions are drawn out of it. So let me just see. So let me say in 2014, the year 2014, the population of the country, or the population of, say, India, is around 112 million. So this is one of the data which I have collected for the year 2014. Now next, I have For 2010, it was 98 million. So the 4 years passed. Let me say in 2006, the population of the country was around 86 million. In 2002, the population of the country is 80 million. So this makes me understand that the population of the country as recorded for every 4 years will draw conclusions in understanding that here, with rise of every 4 years, the population of the country is increasing. That means there are many precautionary measures which we need to take for future years to reduce the population of the country. Because when population increases, there will be a lot of problems arising out of the population of the increase. The scarcity of food, the occupation of land, and various other things which affect the population of the country. So therefore, to control the population, this data will give us an estimation of taking an urgent precautionary measures from the governmental department. So this is how we can draw the conclusions from the data, and this can be one of the best example for the data collection. Now, as we have discussed with the definition of the data and with one of the example as we have discussed in case of population of a country every 4 years. Now, there are two types of data which are taken into consideration, and understanding the difference between the two types of data which we're going to discuss now is very important, because these are the two basic things through which we understand statistics more better. So there are two types of data. One is the primary data, and this is the secondary data. Now, what is the difference between these two types of data? What is the primary data and what is the secondary data? Primary data is the data which we directly collect through our active involvement in the process. Say for example, I wanted to find the community. Say let me take a small village and I wanted to survey how many people are educated in that village and how many of them are not educated. So in this case, I'm just going directly as a person and involving in collecting the data on a piece of paper through inquiry from each and every house and many people out in the residential part. So this is called the primary data because my involvement is direct. Then what would be the secondary data? The population of the country is something which I cannot go directly and involve. I cannot go directly to the entire country and calculate the population of the country. So in this case, I need to take support from either the governmental services or few of the departments, or I can collect the information of the data from the best online sites or the Google search, which can give me the data indirectly. So the data which you get indirectly without your involvement is secondary data, and the data which you can get directly through your involvement is the primary data. The example for this being collecting the literacy or illiteracy rate in a particular village can be a primary data because you are going to directly involve in the process. But collecting the population of the country may not be a primary data because your involvement is impossible to collect the population of the whole country. So that is how I differentiate between the primary data and the secondary data. So let's take an example. Before that, I take the definition. Data collected through direct involvement. This is the definition of primary data, the data which is collected through direct involvement, as we have discussed through the example. So here the example is collecting the data of literacy rate in a village will be the primary data. So what would be the secondary data? Data collected through indirect involvement. So this is the same through indirect involvement. So the difference here lies between the direct and indirect, with the rest of the statement being the same. So data collected through indirect involvement of the information which we collect is called secondary data. So for example here, this can be the best example. The example for this can be the population of the country for every 4 years is one of the best example which can be considered for secondary data, because your involvement directly in collecting the data is impossible. Now with this topic of data, we'll continue further with measures of central tendency. Now this is the core of statistics, because with the data, it is not just the data which is collected which is important, but identifying the central tendency of all the data collected, which is also equally important. Now what is measures of central tendency? Sometimes if I collect the data which is around 80 or 100 of the information, so with such large data, I cannot calculate or estimate each of the data individually. It becomes very time consuming, or the time consumption is too enlarged, because for 100 data or 200 data which we collect, the collecting of each of the data individually and studying the basic conclusion which is drawn out of each of the individual data would become very difficult. So therefore, in that case, we try to study the entire data with only one central value which is said to be depending corely on the entire data. So that is the reason why the measures of central tendency have arisen in the topic of statistics. The core value which decides the fate of the entire data. The core value which decides the fate of the entire data. And let's see how the central tendency is going to help us in estimating or how it depends on the entire data. So there are three types of measures of central tendency in the topic of statistics. One being the first, which is mean. Then the other is median. Thirdly, it is mode. So it is mean, median and mode. So these are the three basic measures of central tendency which have their own respective definitions and which help us in identifying the value, and that value will correlate make us depend on the entire data. So it is the core value of the entire data through which the whole data depends on, to explain in the most simpler manner. So let's start with the first basic definition of mean. Mean here is also called arithmetic mean. Just to note a point, the other name for mean is arithmetic mean, the other name for mean which we call in terms. So let's start with the first measure of central tendency called the mean or the arithmetic mean. So mean is nothing but the average of all the data which is collected. So the definition says the average of the entire data is called mean, and usually it is denoted with X bar. So when I have it is denoted by X bar generally. So let me say I have n number of data. Say for example, if I have now let's take an example where I have the data collected which ranges from x1 to xn. That is, I have the first data which is x1, the second data which is x2, the third data x3, x4, x5, so on and so forth till xn minus 1 and xn. So this is the data which I have collected, say. So how many observations are there? Totally how many number of data are available is the first thing which we record. So here the number of observations clearly is n. There are n number of observations because they range from x1 to xn. So with the number of observations being n, my mean is nothing but average. As we know that average is sum of all the numbers by the number of numbers which are taken into consideration. So here the mean would be nothing but the average of the all data. That means I add the complete data divided by the number of that data available. So therefore, for n observations, so basically these are the observations. So for n observations, I have mean is sum of all observations by total number of observations. So using this definition of mean, sum of all observations by total number of observations, I get my mean by the definition as x bar, which we usually denote for mean, is equal to x1 plus x2 plus x3, so on and so forth till xn by the number of observations, which is n. So this is how I get the formula for x bar, that is x1 plus x2 till xn by n. Next, this can also be written as, this is the formula for mean, which we generally use while solving the problems. And to avoid the long process of writing from x1 to xn, I can also write this in summation notation as sigma I running from 1 to n xi by n, which makes me understand that each of I would give me each of the observation from x1 to xn. I equal to 1 would give me x1, then next summation is plus, therefore I equal to 2, the next value of I would give me x2, then I equal to 3 would give me x3, and then last I equal to n, because I ranges from 1 to n in this case, then the last of n gives me xn. So that this can be written in the shortcut form as sigma I equal to 1 to n xi whole divided by n. So this is the basic formula for mean or arithmetic mean. So let's take an example and see how we can calculate the mean of certain observations or the given data by using this formula which we have calculated. So there's another method through which mean can be calculated, and that is mean by deviation method. Sometimes if the data is very large, suppose I have 500 of the data, then in that case finding the mean by using the previous method of average method is very difficult, because adding of 500 different observations and dividing by 500 would be very time consuming. So therefore, for that large data, we have to use the mean by deviation method. So this helps us for any large data, or it also helps in finding the mean for even decimal places, for decimal values of the data which is collected. So let's see how the mean by deviation method is calculated through the respective formula. So before we understand the mean, we have to understand the concept of assumed mean, which arises in case of mean by deviation method denoted with A. Assumed mean is the mean which the student assumes or the observant observes for the given data. So assumed mean is very important because in deviation method, assumed mean is the core in finding the value of mean. So the formula for mean in case of assumed by deviation method is, by deviation method would be A plus sigma I equal to 1 to n xi minus A by n. So this is how the assumed mean helps us in finding the mean by deviation method. So let's see what exactly is assumed mean. So in this case, assumed mean, which is generally denoted with A, is the mean which the observant identifies through his own calculations, through his or her own calculations. Now in this case, an assumed mean can either be calculated from the entire data by using the maximum value plus the minimum value by 2. So this would be max plus min by 2, and this would be one more where I take the middle value, can also be taken by the observant to find the assumed mean. So the middle value can also be considered for this. Now the next is I can also take the average of the entire data or the general mean from the previous topic, previous session which I've been discussing there. That can also be taken for calculating the assumed mean. So there are three different types of calculating the assumed mean. If the observant has calculated the assumed mean through the process of identifying the maximum value and minimum value and then adding by 2, then max plus min by 2 will give me a different value for assumed mean. But a middle value which is considered from the entire data may give me a different value for assumed mean. An average or sum of all observations by the total number of observations can give me a different value for the assumed mean. So how come that three different values can give me the same mean by deviation method is the biggest question out there. It does give. An assumed mean is independent of how you're going to calculate or what the value is here, because this is again going to adjust through the calculation which you do here through xi minus a in summation. So let's see an example problem where we calculate the mean, assumed mean through each of the methods and see if the answer which we get for the mean by deviation method is the same for all three cases. So let's verify that through each of the individual process which we consider through an example problem for finding the mean of using the deviation method x bar d.